All right, we're going to do the 8-4 notes now. This is finding the area between two curves. So when you do an integral like this, when you do an integral where you got a curve above and below, this is the left x value, left x, to the right x value, and then it's going to be the top function minus the bottom function. And it could be dx or dy, but on this first section, I think they're all dx. So the next section, 8-5, is talking about dy. And it's going to change this stuff also when it's a dy problem. So this is how it works for dx. It's top left x to right x from top minus bottom. And that's how you do it. And here's why, because we want to get the area of this. So this is the left x to the right x. This is the intervals. This is 1 to 3. And then f of x is this top function from the intersection. It's this top function. And then g of x is this bottom function. So that's why it's the top minus the bottom dx. So if we just do the top part, that is the area of the parabola from left to right, just under the curve, which is this. And then this is the area of g of x under the curve from 1 to 3. So if you subtract this part from that part, that's what gives you the part between the curves. So again, this is the left x to the right x values of the graph. And then this f of x is the top minus the bottom. So we're going to graph these, and we're going to do these problems. I'm going to do them as quick as I can while explaining it. So I would recommend graphing these on here. So find the area of the region bounded on the graph by y equals x squared plus 2. So I hope you know plus 2 is a vertical shift to here. And we are doing this from x equals 0 to x equals 1. So x equals 0, I hope you all know, is the y-axis right here. And x equals 1 is this vertical line going up right here. So what that tells me is this is going to be the integral from 0 to 1, because we're going left to right, 0 to 1. So when I plug in 0, I get this. When I plug in 1, I'm going to get 3. So this is the part of the parabola I need. I don't need this extra stuff. Okay, I don't need that part. Those are supposed to be dashed lines, sorry. That's not the part I want. I'm just worried about the part between 0 and 1. And the graph y equals negative x. So when you plug in 0, you get 0. When you plug in 1 for x, you get negative 1. So that is this line right here. So again, this line keeps going, but I don't need anything except the graph between 0 and 1. So the shaded part I want is this part. So I hope you see the parabola is on top and the line is on the bottom. So when I do this problem, we're again going left to right, 0 to 1. The top's the parabola, so this is going to be x squared plus 2, and then minus the bottom one, which is negative x dx. Okay, so that's my equation that I want to do. So first thing you want to do is change these two negatives to a positive. And I'm also going to put them in descending order. So when I do that, I'm going to get the integral from 0 to 1 of x squared plus x plus 2 dx. Okay, and then I'm going to get x cubed over 3. I'm going to do my integral plus x squared over 2 plus 2x. And we're doing this from 0 to 1. So we're going to plug the 1 in first. So we're going to get 1 cubed over 3 plus 1 squared over 2 plus 2 times 1. This is called the upper limit because it's the upper bound, this part right here. Some people like putting that in parentheses, but you don't have to. Then it's minus plugging zeros in for the rest, and this is the lower limit. You do need parentheses around this because you do have to distribute the negative sign. So maybe the 2 times 0. Okay. So that right there is your answer, but we're going to go ahead and simplify this. So this is 1/3 plus 1/2 plus 2 minus 0. And then this would probably be a multiple choice question, maybe, maybe not. So we get common denominators here. So the common denominator is 6. So you take this by 2 over 2, and this is 2/6. This one by 3 over 3, so this is 3/6. And this one by 6 over 6, so this is 12/6. So 2, 3, and 12, I think gives me 17/6. So the area of this curve is 17.6 units squared, and we don't know what the units are. Okay, we're going to go on to the next one. So this one says, between two intersecting graphs, find here the region bounded by this parabola again, and this line, sketch the graph. So these two things are going to intersect. So what I would do is find the intersection algebraically. So they're going to intersect when 2 minus x squared is equal to x. So we want to get this equal to 0. So I add x squared over, I got plus x, subtract 2 over. This factors to x plus 2 and x minus 1. So x is going to equal negative 2 and x is going to equal 1. So there's going to be my intersecting. So that tells me that I'm going to go from negative 2 to 1. So I'm going to plug negative 2 in here. So negative 2 to the fourth or second is 4. So 2 minus 4 is negative 2. So negative 2, negative 2 is here. And then I'm going to plug in negative 1. So negative 1 squared is 1, and 2 minus 1 is 1. I'm going to plug 0 in and get 2. And I'm going to plug 1 in and get 1. And that gives me from negative 2 to 1. So this part right here is the parabola I want. And again, the parabola keeps going, but all I'm worried about is there because of these intersections. And then I want to graph a line g of x equals x, which is y equals x. So you plug in 0, you plug in 1, you plug in negative 1, you plug in negative 2, and you get this. And again, this line keeps going, but this is the only part I worry about because it wants where they intersect. So the shaded part I'm finding is this part in here. This is the area that I'm looking for. So the top graph is the parabola again. It doesn't always work out this way. So it's going to be 2 minus x squared minus, and then this part is the x. So it's minus dx and dx again. So I'm going to do what I did a minute ago. I would probably, now it doesn't matter. I'm just going to do the integral the way it is. So I'm doing, this would be 2x minus x to the third over 3 minus x squared over 2. And I'm going to do that from the lower bound to the upper bound, negative 2 to 1. So we plug in the 1 first. So this is 2 times 1 minus 1 cubed over 3 minus 1 squared, 1 squared over 2 minus, and I got to put a parenthesis here because I got to distribute this minus the lower bound. So 2 times negative 2 minus negative 2 to the third power over 3 minus negative 2 squared over 2, like that. And that would be fine for your answer in this class, but we're going to go ahead and simplify it. So this is 2 minus 1/3 minus 1/2. This right here is negative 4. Now let's go ahead and do that. So I get negative 4, and then negative 2 cubes, negative 8. So minus a negative is positive 8/3. And then negative 2 squared is 4. 4 over 2 is 2. So this is minus 2 right here. So I'm going to go ahead and distribute the negative. So this becomes plus, this becomes plus, this becomes minus, this becomes plus. So I'm going to combine all of my integers. So 2 plus 4 plus 2, that's 8. And then I got negative 1/3 minus 8/3, that's minus 9/3, which is minus 3. And then I got minus 1/2. So 8 minus 3 is 5. 5 minus 1/2 is 4.5, or 9/2, or 4.5. But that right there is going to be the area of that part. Okay, I'm going to go on to the next problem. We want to find the area enclosed, area of one region enclosed bounded by the graph. So we got to know the sine and the cosine graph. So I hope we all know that sine goes through the origin. Pi over 2 is a max at 1. Pi is a 0 again. 3 pi over 2 is a minimum. Back to here, back to here, back to there. So there's my sine graph. And I'm going to hold off on graphing that because all I'm worried about is the intersection. So cosine starts at a max, goes to a min. I'm going to go the other way here. Goes to a 0, goes to a min. So this graph kind of goes like this, and then right in here somewhere is where they're going to intersect. And this graph goes, oh my, that's not very good. Let me make this better. So this graph is going kind of like this. Now it keeps going down here, but I don't really care about that part. And then the blue graph, the sine graph, is coming down like this. And then they're going to intersect in here somewhere. That's where I'm worried about. And then they're intersecting here again. And again, if you want to keep going, you can. But if you recall, it said we're only worried about one intersecting area of them. So I'm going to do this intersecting area of the two graphs right here, this part. I'm going to find this area. Now this is kind of nice because there's only one graph on top, and I hope we all know that's the cosine graph. So I need to find out where this point is and this point is. Well, if you think about the unit circle, the only two places where these graphs equal are down here. They're both negative radical 2 over 2. And up here, they are both radical 2 over 2 off the unit circle. So what that tells me is this is at pi force this way. So this right here, in other words, this intersecting point right there is pi force. And then I got to go this way to get to this point, which is negative 3 pi over 4. So this intersecting point right here, where these two graphs intersect right there, is negative 3 pi over 4. So there's my left and right values. So that's kind of hard to do. So this is negative 3 pi over 4, 2 pi over 4, and the cosine's on top all the time. So it's cosine x minus sine x dx. So now the integral of cosine is negative sine, and the integral of sine is, wait a second, I got that backwards. The integral of cosine is sine x. The integral of sine is negative cosine. And we are doing that from negative 3 pi over 4 to pi over 4, our lower bound and our upper bound. Okay, so two negatives make a positive, so this is going to be sine pi over 4 plus cosine pi over 4, because the two negatives make a positive, minus, you got to go parentheses, sine of the lower bound, which is 3 pi over, actually negative 3 pi over 4, plus cosine of negative 3 pi over 4. Okay, so that right there can be your answer in this class, but we're going to keep going because we're going to plug in our values. So these are the pi over 4 values. So this is radical 2 over 2 plus radical 2 over 2 minus, and the sign down here, these are both negatives in the third quadrant. So this is negative radical 2 over 2 plus negative radical 2 over 2. So these all have complement. Let's go ahead and change this to plus and positive. So we're going to make this plus, which changes this to plus, which changes this to plus, distributing the negative. So we got 1, 2, 3, 4. We get 4 radical 2 over 2s. So this will reduce this to 2 radical 2. This would be our area of that graph on example 3. So got to know some trig on your test. And I guess that's the last one we got. So good luck to you on this part. Again, one of the key things you need to realize is it's going to be the left x to the right x, top function minus bottom function dx. I'm going to show you a little deal here. Sometimes you get some kind of crazy graph. Sometimes they go like this. And we're going to do this later, but they have 3 intersecting. Have 3 intersecting points, like this is some A and some, I don't care what that is, and this is some B and I don't care what that is, and this is some C and I don't care what that is. And let's say the blue graph is F. And let's say the black graph is G. And you have one like this, what's on top switches. So what's on top here is the black graph. So we would say the integral from A to B is the G the g function minus the f function dx. So that would be this area. And then the blue one goes on top, so it'd be plus the integral, and now we're going to go b to c. And since the blue's on top, it's the f function. It would be f minus g of some dx. So sometimes, and this, they usually have one like this on the AP test where there's two different ones on there. And we're going to learn how to find these intersection points on our calculator. I'm going to save those in A, B, and C, and then be able to find those. So anyway, have a good day, and I will see you in next class.